Okay, this is the number 62. Okay, getting ready for semester 2 finals, number 2. All right, so let's get started. Again, we're going to have a very similar format. Start with factoring, go to solving, and then go to graphing. Same as the first one. Now, number 1, I'm actually going to show you 2 ways of doing it, because depending on how you look at this, you might go 2 different ways with it. Okay, so first thing you probably do is recognize that these are perfect squares. Right? 36, 16, not random. Okay, probably a good sign because it'll make it a little easier if you recognize that. So we have 36x squared, which is 6x times 6x, right? And then we also have 16, which is just 4 times 4, right? And then to get to negative 48, since it's negative, both of these will be negative, right? Because we'll get negative 24 from here and negative 24 from here, and that equals negative 48. Okay, now the problem with this answer is that it's actually not fully simplified, because if you can, you should always take out GCFs. So you see on this one how 2 goes into both of them? So you can really just take out a 2 from each of those, divide each by 2, and you'll have 3x minus 2. And you can also take out a 2 out of each of these. So you can take out another 2 and have 3x minus 2 again. And then just take those 2 and make 4. Okay, so 4 times 3x minus 2 times 3x minus 2. If you really want to get fancy, you can write this as 4 times 3x minus 2 to the second power. Okay, so either one of these would be acceptable as the final correct answer, but you don't want to stop at this point. Okay? So another way of doing this is, step 1 is always a GCF. So before you do anything else, just do a GCF all the time. It can never hurt. So you see how there's a number that goes into all of these? Okay, the biggest number is actually 4, the thing that we ended up taking out at the end. So we'll just do that at the beginning instead, and it'll probably make the process a little easier. So if we divide each of those by 4, right, you might be thinking, oh, I got 36 and 16, nice perfect squares, but now I won't have that. But even after you do the GCF, look, you still get 9, right, and you get 4. So you still end up with these perfect squares, even if you do take out the GCF. So, and now from here, it's a little easier, because what multiplies to 9x squared, 3x and 3x, right? Same thing we got here. And what multiplies to the 4, we get 2 and 2. And once again, to get the negative 12, make them both negative. So you see how we get the same answer here, but it's a little bit shorter. Okay. But it doesn't really matter. It's not wrong or right. It's just you have to get the same answer either way. You can't stop early. So either one of these forms would probably be correct. So takeaway, GCF, always do that first if possible. Speaking of GCF, number 3. Okay. So what do you notice that both of these have? Okay, so both have an x. You can't take a number out of 9 and 25, at least not the same number other than 1. So you can only take out an x. 9x squared minus 25. And once again, these nice perfect squares, not a coincidence. That means, and it's subtraction, that means you can factor it further. You must factor it further. You can't just say, well, the first step is GCF, do that, and then stop. You have to look at, well, what are you left with, right? And what you're left with be factored even more. So once again, what multiplies to 9x squared? 3x, 3x. What multiplies to negative 25, right? Positive 5, negative 5. And there you go, that's fully factored. Since we're only factoring, we're stopping. It's not equal to 0 or anything, so we don't have to find x-intercept. Okay. Alright, let's go down to number 3. Do the solving by factoring. So now there's an equal 0, so our end result will be 2 x-intercepts. I have 2 answers at the end, and if I graph it, that's where they cross the x-axis. So start off with the GCF once again. See how 2 goes into both of those? So you can see a lot of these problems are different, but how you solve them, it's really repetitive. It's gotta get really used to doing the same thing again and again. And just like a number 2, look, we got some nice numbers, 9 and 1. So we can factor that even further. Alright, so to get 9x squared, we get 3x and 3x. And to get 1, that's easy, just 1 times 1. And negative 1, so 1 positive, 1 negative. And now we are solving. So we gotta set both of these equal to 0. So 3 times what plus 1 equals 0, and 3 times what minus 1 equals 0. And again, we don't care about this 2 because we can just divide by 2 on both sides. It equals 1, cancels out, and equals 0 here, so this 2 doesn't affect the answer at all. Subtract 1 on both sides, we'll get 3 times what equals negative 1. Divide by 3, so we get negative 1/3 for one of the answers. And in a similar way, we'll have the opposite on this side. We get positive 1/3. So if we graph this, they would intersect at positive 1/3 and negative 1/3 with the x-axis. Okay, so fractions are okay. Here, leave it at fractions because don't put this as a decimal. Don't put 0.3 because it's really 0.33 is repeating. And we don't want to put repeating stuff for intercepts. Just leave it as a fraction. Alright, so 4. A little more straightforward. We just have to do the old-fashioned multiplies to 1 times 12. 12. And adds to negative 8. So we have, let's see here, 3 and 4, but that adds to 7. So let's do multiplies with 12 would be 2 and 6. That adds to positive 8, so to get the negative, I want these both to be negative. That still multiplies to positive. So we have x minus 2, x minus 6 equals 0. And then we have x minus 2 is 0, so one x-intercept is 2. And we have x minus 6 equals 0, so we'll have the other one, x-intercept is 6. So if we graph this, it would cross the x-axis at 2 and 6. And that's what we'll do on number 5. Actually graph these out. Okay. So here we have a nice perfect square. We have 1x squared minus 9. So you're seeing a lot of these 9s. That's to get you really comfortable with seeing perfect squares and thinking, if you see 9 or negative 9, you'll know that's positive 3 and negative 3, right? So your x-intercepts is if you just set those equal to 0. Okay. And you'll get negative 3 and positive 3. Those are your two x-intercepts. So it's going to be on either side, here and here. Axis of symmetry is right down the middle, right? So it's just x equals 0. So the vertex is the axis of symmetry as the x. Now the y is when you plug in 0, what do you get? If you plug in 0 into here, right, you'll get 0 plus 3 is 3, and then 0 minus 3 is negative 3. So 0 times negative 3 is negative 9. So there is your vertex. Way down here, negative 9. 0 comma negative 9, which happens also to be the y-intercept. So if your axis of symmetry happens to be 0, well then your vertex is going to be the same as your y-intercept. Doesn't happen often, but sometimes. And once again, because it's opening upward, right? This is opening up. We know the vertex is a minimum. Right? This is the vertex. It's at the bottom of the graph, right? It's up here, and it goes way down, and it starts going back up, so it's a minimum. There we go. Alright, let's head over to the back. One more review with the rational and irrational numbers. We have the rational part, negative 10, and the irrational part, the radicals, which would be root, square root, 21. And again, you're looking to see if this reduces. So you're asking yourself, does 4, 9, 16, 25, any of these perfect squares go into 21 evenly? And in this case, it doesn't. So that's finished. It's kind of like a fraction that doesn't reduce. If you got an answer of 3 over 7, it doesn't reduce, so that's your answer. There's nothing else to do. But if we happen to get an answer of like, 2 over 4 in some fraction problem, we have to reduce it to 1/2. So that's kind of what we're doing. It's like reducing a fraction all the way, but instead a radical. And we can't just reduce it by dividing top and bottom by any number. We have to be able to divide whatever's in here by one of these perfect squares. Otherwise, we leave it alone. Okay, number 7. Okay, so we'll get 10. And then here we'll get root 60. So you're asking yourself, what perfect square goes into 60? What's the biggest perfect square that goes into 60? So 60 divided by 49, no. 60 divided by 36, no. 60 divided by 25, no. 60 divided by 16, might want to check that on the calculator, but no. 9 doesn't go into 60, but 4 does. So after all that, we can only take out a 4. And you have to figure out, well, 4 times what is 60, and that's 15. So I just broke up 60 into one number that is a perfect square and then something else. And of course, keep bringing that down. Now, square root of 4, that's 2. And we can just bring everything else down. And then lastly, these two together make 20. So we got 20 times the square root of root 15 as the final answer. And if you have a calculator, you can actually find these decimals, type them in. Square root of 6 times 2, get a decimal. Square root of 10 times 5, get a decimal. And then go ahead and type this in, square root of 15, and multiply it by 20, and it will be the same exact decimal. So it's just simplified. Instead of having all these numbers, 4 different numbers and 2 different square roots, you get the same answer with one number and one square root. That's why I call it simplified. Okay, let's go down to number 8. All right. So just remember that you can always write these out long ways and say, well, 3x squared is 3 times x times x, and 5x to the third is 5 times x times x, and you can just, well, I know what 3 times 5 is, that's 15, and I see 1, 2, 3, 4, 5 x's, so that's x to the 5th, and nothing more to it. Okay. Very straightforward. So writing everything out does work, and it's a good way to check your answer if you have extra time. Okay, so let's do a little more practice, this time with 2 variables. So we'll have negative 2 times 6 is negative 12. Okay. I have 5 x's here, 4 x's here, so altogether I'll have 9 total. See how I just add them up because I'm counting them up. Here I have 1 y, and here I have 8 more, so altogether you have 9 total y's. So that's y to the 9th. So there's the final answer there. A few more. Let's just do division. Okay, you can always write it out. So we have 8 with 1, 2, 3, 4, 5, 6 x's. And then on the bottom you have 12 with 1, 2, 3, 4 x's. And just see what cancels out. So for the numbers, like 2 or 4 goes into both. So that divided by 4 is 2. This divided by 4 is 3. And you have 1, 2, 3, 4 x's, sets of x's that cancel out and equal 1. And you're left with 2 on top. So we're left with coefficient of 2, 2 x's, which is x to the second. And on the bottom, we're just left with 3. So 2x to the second over 3 is the final answer. Another way of looking at that is you can just take these and subtract 6 minus 4 and get 2. But you got to know where to put the x to the second. Does it go on the top or the bottom? So that's why this will help you check that. And then, of course, 8 over 12 reduces the same way it always has. Okay. One more like this. So let's reduce negative 15 over 21. So 3 goes into both of these. So divide both of those by 3, and you'll get 5 and 7. So we'll have negative 5 over 7. Okay. We have 2 x's on top, 9 on the bottom. So these two will cancel out with 2 of these, leaving 7 x's, or x to the 7th on the bottom. Okay. And then we have here, we'll have 6 on top, 2 on the bottom, so 2 of these will cancel out with 2 of these, leaving 4 y's, or y to the 4th on top. So we have negative 5y to the 4th over 7x to the 7th as our final answer. Alright, so that concludes with the second review. Okay. And just keep on going. Remember, you want to be able to do this entire review by yourself with no help and get 100%. And don't stop working on it until you're able to do that. Okay, good luck.